Namaste students, welcome back to the web technology video learning series. We have started understanding basics of JavaScript. Last lesson we have gone through what is JavaScript and then how it fits into the overall ecosystem for the web. We have seen that along with HTML and CSS, JavaScript forms one of the core technologies for the web, and it predominantly provides the dynamism and interactivity as far as user is concerned. Let's start looking at the specific language basics for JavaScript. So far, you know that JavaScript is an interpreted language. What is an interpreted language? We said that JavaScript has a virtual machine that goes through each of the instructions that are in the code and executes them. That is a true definition of interpreted. But then we have to go one step deep. Now let's try to understand what is interpretation from a human analogy. When two humans speak, we speak in terms of letters, in terms of words, and then the words make sentences, and sentences make paragraphs, and so on and so forth. Think about how our brain understands what is being spoken by the other person. What we hear is really sound. Our brain hears the sound, tries to formulate letters out of it, tries to formulate words out of it based on the punctuation, tries to make sentences out of it based on the punctuation. So what it really does is, it has a huge set of sounds that it tries to parse or tokenize and tries to form individual words that it can put a meaning to, or it can understand. Each of the word that it gets has a meaning, or it has some reference somewhere else, right? So this process that what brain goes through while we are hearing somebody else speak is called tokenization. So it is basically parsing all the sounds that it is getting, and it is converting them into individual words. Now once we have words, the words will go through words will be converted into sentences, and then from there onwards it can be anything. We can interpret the way that we want, because we have a meaning associated with each of the words, and then therefore sentences. The key process here is words and tokenization. Let's assume that the brain right now has deciphered all the sounds and has gotten converted it into a sequence of words. Now, what kind of words can be there? Some of the most popular types of words can be names. For example, when somebody says Rama killed Ravana, both Rama and Ravana, these are names. So the first kind of words are names. Then the second kind of words are actions, what we typically call as verbs. In the example Rama killed Ravana, killed is a verb, and then we have some meaning associated saying that it is a past tense, and so on and so forth. Like how we have different kinds of words in our human language. Let's say somebody says, my age is 25. Now we know my is a type of word, is a type of word, and then 25 is another type of word. Not all these things are the same type, right? So we typically classify, if you go to the language grammar, English language, we classify the words into different types of words, verbs, nouns, pronouns, and so on and so forth. And you can also see that the classification and the means of interpretation is specific to the language. The brain is actively interpreting every word that is being said and then it is trying to convert that into a meaning that it can understand. In a interpreted language or a scripting language, they are used synonymously typically. Computer goes through the same process as our brain. When we write lot of code in a file and then give it to the interpreter or the virtual machine, it tries to tokenize them into individual words. Parsing into words is an equivalent of saying tokenizing into tokens. So end of the tokenization process, we have lot of words or lot of tokens, and then it tries to understand each of them. Like how we have for our human languages different types of words, computer languages also have different types of tokens. Like how our language grammar defines these words in our human language, the computer language's grammar specifies what kind of tokens are to be expected. The computer languages are, of course, much more primitive and very little in terms of how much it can do compared to our human languages, in terms of the extent and in terms of the conciseness of the grammar, and so on and so forth. But the parallel is similarity. So back to our subject, JavaScript is a interpreted language and it has a grammar, and it has certain types of tokens that are to be allowed in a JavaScript code. What kind of tokens are there in JavaScript? There are typically 4 kinds of tokens: identifiers, keywords, literals, and operators. Identifiers or names. I am assuming you already have some bit of familiarity with at least one more programming language. Especially if you're learning this for your college, you must have definitely read C or C++ or Java earlier. So we will try to build upon the similarity with the other languages that we have, as opposed to learning it fresh. Identifiers are those tokens which are really names, and in programming, in our programming languages, the names are really the names of the variables. These are called identifiers. Each language has a set of keywords. These keywords are special purpose words that have predefined meanings. Literals, or the example I gave you, 25 or 45 or something else, these are literals. Literally speaking, they are literals. There are 5 different kinds of literals: integers, floating point, boolean, strings, and special characters. We will go through them. And then there are operators. These are either mathematical or relational and so on. These are the operators. Together, all these tokens create a language grammar for JavaScript. Any programming code that we have with JavaScript is essentially formulated out of these kind of tokens. So the interpreter, once it tokenizes, it will try to understand what each of the word or token that it is reading from the file into each of these buckets. If it cannot match them into one of these buckets, then it throws up an error. It says, I don't know what this token is, help me out. And then once it understands each of the all the tokens that are there, then it knows how to execute, because the language specification says what to do for each token. Let's look at identifiers. Identifiers are names of the variables, and the names of the variables are not, they cannot be named just like anything. The names have some rules. Each programming language enforces certain rules on how the variable should be named. The first rule is that the first character in an identifier name must be either an alphabet or an underscore. So we cannot have, okay, let's go through the other rules. After the first character, subsequent characters can be alphabets, digits, or underscores. You can see now from the second rule, it is adding digit, which means that the first character cannot be a digit. No. Because I can use an underscore, there is a rule that says 2 consecutive underscores are not allowed. Then, identifier name cannot be the same as a JavaScript keyword. If there is a predefined keyword that is part of the language, then we cannot use the same name as an identifier name. And lastly, commas or blanks are not allowed as part of identifier names. No special characters other than an underscore is allowed. And then identifiers are case sensitive. What is case sensitive? If we have capital letters and small letters are the two cases that we have. If there are two names and they are different only because some letters are in a different case, then they are two different variables. That is what it is meant by case sensitivity. Now let's look at some examples on the right hand side. The first name, Rama, is a good identifier name. It meets all the requirements. The second name, underscore Krishna, is also a good identifier name. The third name is a bad identifier name. Why? Because it starts with 1 and therefore it does not meet the first rule. The third variable name is a good one. It does not make sense as a meaning, but it's a valid identifier name. So is the fourth one. The fifth one is an invalid identifier name. Why? Because it uses 2 consecutive underscores which are prohibited by the second rule. The next one is a bad identifier name because it is using the same name as an existing JavaScript keyword. And the fourth and fifth, the last two variable names or identifier names are invalid because they are using special characters. Okay, I hope you understood what is an identifier and what rules are there for each of the identifiers. Let's move forward. The table is a massive list of all the keywords that are there in JavaScript as of today. Typically, maybe you will find that in your textbook you don't see this bigger list. You will rather see a smaller list. Why? Because this list that you have on the screen is an up-to-date one, and as I said, the JavaScript language specification keeps changing with time and more keywords keep getting added. So therefore the list that you have on screen is an all-encompassing list as of today. The key thing here is you cannot use any of these names as an identifier name. We'll introduce each of the keywords as required in our subsequent classes. No need to memorize them as of now. Keywords are just special tokens that have predefined meaning. Now literals. Literals are those that if you are parsing a code, and if the computer is parsing code and it cannot find that a particular variable is a particular token, whether it is not an identifier, then it is not an operator, or it is a keyword, then it tries to think that it is just a literal. But then there are only specific kinds of literals. Anything else is not a valid literal. What are the literals that are valid? Integers. These are numbers expressed in decimal form or octal form or hexadecimal form. For example, when somebody says a is equal to 5, a is an identifier, is equal to is an operator, and 5 is a integer, literal. Like integers, we have floating point literals also, and the floating point numbers are really numbers with fractional parts, and they are expressed in either in standard notation or in scientific notation. Typically, most of our programs we use the standard notation only. And then there are Boolean literals. There are only two possibilities here, true and false. Then there are string literals. What are string literals? String literals are those with 0 or more characters. 0 here is important because it means that nothing else can be there. So string literals are those that have 0 or more characters that are enclosed in single quotes or double quotation marks. Any of them are called string literals. And then there are the last type of literal is a special character. These special characters are historically carried forward from JavaScript. These have special meanings that we don't really need to bother about them right now. Just to understand that there are special character literals. I hope you understood what the literals are. Then the operators. I think coming from any other language, the operators must be familiar. There are arithmetic, relational, assignment, unary, conditional, logical and bitwise operators. These have the same meaning as they have in most of the other languages. So we don't really need to spend much in terms of understanding these operators. I hope you are already familiar. This is here for completeness. Okay. Now comes variables and data types. On the right hand side, you have an example. Let's go through them. JavaScript uses the var keyword to declare a variable. If you are familiar with C, if you want to declare an integer, you will say int I is equal to 5. So int is a data type, I is the identifier name, and 5 is the initial value to be assigned. JavaScript does not have explicit data type assignment. Rather, all variables are declared with var keyword. In the later JavaScript specifications, there is a let keyword also that can be used, but for our purposes, we'll just use the var keyword. So, we'll use a var keyword to declare a variable, and the name of the variable must conform to all the identifier naming rules. You can see lines number 3 to 6. These are all different simple variables that are being assigned different kinds of literals. You can see A is having a value of 5, B is having a string Rama, pi is a variable that is a floating point literal 3.14, and then C is a variable which is a Boolean variable. JavaScript automatically deduces the type of the variable based on the value that is being assigned. Therefore, there is no explicit data type specification for variables. This is very different from some of the statically typed languages or strongly typed languages. Now, talking of primitive data types which are natively supported, there are three kinds: numbers, strings and Boolean. These are the ones that you have seen on the examples from line number 3 to line number 9. There are composite variables which are essentially called objects. So you will hear this term objects quite a bit in JavaScript. JavaScript naturally or natively supports objects. These are to be defined in a notation called JSON. JSON is a short form for JavaScript object notation. They are assigned in key value pairs. You'll take a look at line number 12. Book is an object. It has two attributes. The first attribute is called name. Second attribute is called author. The value for the attribute name is Ramayana as a string, and the attribute author has a value Valmiki as a string. So book is a composite variable, which means it is a combination of more than one or more variables inside. So such a composite object, some data variables are called objects. Now this is one way of defining an object. There are other means too. Let's look at statements. Statements are essentially valid sequences of tokens delimited by a semicolon. You can see line number 3 is a statement. It says A is a variable and it has to have an initial value of 5 assigned to it, and it is delimited by a semicolon. So this is a complete statement that JavaScript interpreter can execute. This is essentially a valid sequence of different tokens that together make sense. Now pay attention to the delimiter word. Delimiter is a character that separates two valid statements. Now these statements are all instructions to the virtual machine or the interpreter which is running inside the browser. Once the instructions are made available, the browser executes each of the statements one by one in that sequence. Now if you don't have more than one statement in the same line, if each statement is on a new line by itself, then the semicolon is really optional. You don't need to put semicolon for everything, even though as a convention we keep putting the semicolon. There are comment lines. You can see line number 2, line number 8, line number 11, line number 14. The comments are those that are essentially meant for enhancing readability, but these are just ignored by the browser or the virtual machine that is running inside the browser. There are two kinds of comments. One is a single line comment, which is with the 2 forward slashes, and there is a multi-line comment, which is much like C and C++ and in Java. So we don't need to go further into it. The comments are very similar across programming languages. Then there are arrays. What are arrays? You can see there is an example on the right hand side. Arrays are essentially group of data items. The group of data items, each of the items can be primitive type. What is a primitive type? Primitive types are numbers, strings and booleans or objects. So arrays can be a group of objects, or arrays can be mixed as well. You can have some data members which are primitive data types, some which are objects. This is a difference compared to what we know in C or C++, because array has a very strict data type. It cannot have a mix. Arrays are indexed in JavaScript and the index starts from 0. This is very similar to what we have in other languages. There are different kinds of creation of an array. You can see on the example line number 2, an array called books is created with 3 elements in it: Ramayana, Bharatam and Bhagavatam. Then there is another array called kings that is getting created in line number 5, but it is getting created empty, and then it is populated after it is created. It is getting filled with the names Vikramaditya, Jayaditya and so on and so forth. The array can also be created using a new keyword. In fact, all JavaScript objects can be created using the new keyword, even though we discourage using the new keyword for standard built-in objects. They can be just used because more objects that we create, slower the JavaScript execution will become. Arrays are special objects, which means that there are some special properties that you can use to understand more about the data. Look at line number 12. Variable k is looking at the array queens, and this using the property length. Queens.length will give the number of elements in the array. How many elements do we have in the queens array, which is created in line number 13? There are 3: Rudramma, Padmini and Jhansi Lakshmi. So the number that is returned with the length property k will have number 3. Okay. Likewise, there is a sort function that is automatically available for each array, which will sort all the elements in the array with the default array sorting mechanism. So you can happily and quickly sort without really having to lot of code. Let's look at some of the built-in objects. There are some objects which are built-in. And one difference between other programming languages such as C++ and Java, and JavaScript is that C++ and Java require a class to be specified for somebody to create an object. In JavaScript, there is no such restriction. You can create an object from within another object, and there are some built-in objects. What are the built-in objects? The first one is a number object. You can create a number object using the new operator as shown in the example. String object, an array object, a date object. A date object holds the current date. You can pass different parameters to the constructor here to get different dates. Math object is one that you don't really want to reinstantiate. You don't use new operator there. Rather, we use the math object to use lot of member functions that are part of the math object to do the mathematical operations. You will see that in one of the next slides. And then there is a boolean object. You can create a boolean object using the new parameter. As much as these are all the built-in objects, and you can create a new object out of this using the new operator as shown in the examples. It is really discouraged to create a new object for these built-in objects using the new parameter, because we should be able to manage without using a new object created. Because for example, you can just use false instead of creating a new variable object with the new operator, right? Likewise, it is discouraged for performance reasons to keep creating new objects out of the built-in objects unless it is extremely required. That's it for today's class. I hope you understood the basics of JavaScript language, how it is similar to other programming languages that we already know, and how it is somewhat different from the programming languages we know. I suggest you go through this video maybe a couple of times or thrice to get more understanding on the similarities. We will see each other in a next class. Thank you.